So I thought I would make this video so that you can actually see how to do the calculation. So a solution A is mixed with sulfuric acid and hydrochloric acid of unknown concentrations. 20 ml of solution A was required to neutralize sodium hydroxide. Now the first thing you need to be aware of is that once you have put an acid with a strong base, it will fully ionize. So the hydrochloric will fully ionize to hydrogen ions plus chloride ions, and the sulfuric acid, even though the second stage is weak, will fully ionize as well because it's been put with a strong base. An excess of barium chloride was added to a separate 20 ml sample of acid and of A, and this was resulting in a precipitate of 0.5 grams. Okay, so here's our solution. We've got 40 ml in our mixture of acids here, hydrochloric and sulfuric. 20 ml goes to the titration. And this is just hydrogen ions, and it's titrated against sodium hydroxide. So 0.715 molar and 10.5 ml. The other 20 ml, which is the mixture of the acids, is put with barium chloride. Now the barium chloride will precipitate the sulfate ions, so we need to write an equation. So we've been told that there's a 0.5 gram sample of barium sulfate, so the number of moles of barium sulfate is equal to mass over formula mass, which is equal to 0.5 over 233.37, which is 2.1425 by 10 to the negative 3 moles. So all of those tell us the number of moles of sulfates. So the number of moles of sulfates will be the same. Now, those sulfates came from sulfuric acid. So we know that sulfuric acid, when it was put with a strong base, fully released them. So if you've got this many moles of sulfates, the number of moles of hydrogen ions will be twice as many. Which is equal to 4.285 by 10 to the negative 3 moles. Okay, so I'm going to stop there for a moment and go to the other side of the equation, the other part. So here we had hydrogen ions plus hydroxide ions gives water. Now it's easier to just treat them as hydrogen ions because that's all they are. It doesn't matter where they came from, they're just hydrogen ions. So the number of moles of sodium hydroxide is equal to the number of moles of hydroxides, which is equal to CV, which is equal to 0.715 times 0.0105. It comes out to 7.5075 by 10 to the negative 3 moles. Now this will give us the number of moles of hydrogen ions. So this is the total from both hydrochloric and sulfuric. So it's 7.5075 by 10 to the negative 3 moles. Now what we're going to do is we're going to use those totals plus the number of moles of hydrogen ions that came from sulfuric to find the number of moles of hydrogen ions from hydrochloric. So the number of moles of hydrogen ions from hydrochloric will equal the number of moles of hydrogen ions from sulfuric, the total, minus the number of moles of hydrogen ions from sulfuric, which is equal to 7.5075 by 10 to the negative 3 minus 4.285 by 10 to the negative 3, which is equal to 3.222 0.459078 by 10 to the negative 3 moles. So, now that we've got the number of moles of hydrogen ions from hydrochloric, we can find the mass of hydrochloric. Equals number of moles times formula mass, which is 3.222459078 by 10 to the negative 3 times 36.458, which comes out to 0.11748 grams. And this was the mass in 20 ml. And we can do this because both sample sizes are the same. So the concentration of hydrochloric is equal to mass over volume, which is 0.11748 divided by 0.02, which comes out to 5.87 grams per litre. I hope this is a bit clearer.